today's class, we'll be discussing the evolutionary process models. Now, what are evolutionary process models? Evolutionary process models are iterative. Now, what does iterative means? Iterative means those are continuous models. These are going to be developed continuously. And these evolutionary models, they are going to help you to develop a more complete version of the software. Now, unlike as we have seen within the incremental model, we have seen that we are creating first we are delivering first a core product. That is the basic functionality we are delivering it to the end user. And upon this core product, you're going to add many other updates onto the software. Whereas this is not the case in evolutionary process model. In evolutionary process model, you're going to make one complete version. You're not going to go for updates, but you're going to combine all of this together and you're going to deliver this at once. A complete software will be delivered at once within an evolutionary process model. Now, there are a few types of evolutionary process models. There are three basic types of evolutionary process models. Now, before that, we'll discuss when are we going to use the evolutionary process models. Now, we're going to use the evolutionary process models when a minimal version of the software is not required. When a minimal version is not required. Now, a minimal version means you do not want only a basic functionality to be delivered. You want the entire complete software. Let me again give one more example for this. Now, if suppose someone wants a Word document to be developed, or like word processing, you will need the Microsoft Word software to be developed. So within, if we use incremental process model, you might first have, at the first increment, you might only have like the basic functionalities, basic editing requirements. Then within the next increment, you might get some more advanced features like page layouts, headers, footers. Then you might get some graphics to add or animations to add. You might get different features within different increments. But when this is not required, you go for evolutionary. That is, all of these things should be delivered at once. Now, the second point. Just a moment. The first one was a minimal version is not required. And the second one is when requirements are not clear. Now, when requirements are not clear, this means that whenever software needs to be developed, suppose an end user comes in, just tell, he does not have a main requirements listed. He does not have a list. He just have a main idea that a software needs to be developed. So at that time, you're going to go for evolutionary process models. And the third one is this evolutionary process model technique. This is basically used for complex projects, because in complex projects, requirements are not fixed. Because in complex projects, what might happen, a specific requirement, you might have a set of requirements. A few days later, while you're still developing, a new product might be launched within the market, which requires some more addition to your requirement. So you are going to change your requirements. At these three instances, evolutionary process model is used. Now, there are three types of evolutionary process models. The first model is called as prototyping model. Now, in here, the word prototyping, it means that you're going to create a model. Prototyping means developing a particular model. Now, another name for prototyping, it can be called as a throwaway model, because in here it is not a complete version, it is just a representation, it is just a model. That is why it is also called as a throwaway version. Now, in a throwaway version, you might completely discard whatever you have developed and again start from the beginning, or else you might use a few tools from it and you might use it within your complete version of the software. Now, when are we going to use the prototyping model? The question arises is, when are we going to use the prototyping model? Now, this prototyping model is used when the customer has defined a set of objectives, but he does not identify the input, the output that needs to be there within the software. We'll take an example. Now, if suppose the end user comes in and he tells that he wants to develop a software as there's an increase in accidents day by day, and before the ambulance or any aid reaches the particular person, there's a huge risk for the person's life. The person's life is in danger. Now, in here, he does not completely know what needs to be the input or what needs to be the output, or what are the processing requirements, how you're going to process all of this information. This end user does not have an idea. Now, when the end user itself is not clear, it makes the developer also confused. So at this instance, you go for the prototyping model. This is the first instance when you're going to use the prototyping model. The second one is the developer is not sure about the efficiency of algorithm. Now, in here, there might be a time that the developer might not have used a particular algorithm for a specific type of project. Now, in this case, you're developing an application for identifying where an accident has occurred and how you're going to provide aid to that particular person by sending an ambulance. So in here, you might not know how this algorithm might function when you're applying it to this type of project. So at that time, you are again going to go for the prototyping model. Then the next one is when the developer in here is not sure of how the human and the machine are going to interact. Now, in here, machine is your software. You're not sure how these both are going to interact. So again, you go for prototyping model approach. Then the fourth one is the developer is again unsure about the adaptability of the operating system. So you can see points 2, 3, and 4. These focus upon the developer, and the first point in here is focused upon the end user. Now, because the end user is not clear, you go for prototyping, or else when the developer has got confusion within how the efficiency or how this algorithm is going to work upon this project, or how this human is going to interact with the software that is being developed, or on which software or which operating system this software is going to run, how well it is going to run. When you've got these type of questions, you go for prototyping, because it is a model, it is not a complete version. If you are going to develop a complete version where you're unsure of the algorithm, where you're unsure about the interaction, you're unsure about the adaptability, it is going to cost you more. So that is why you're developing a model. You're going to go for the prototyping model. So I told you prototyping is used when the customer defines a set of objectives that does not identify the input, output, or the processing requirements. The example of the accident software that needs to be developed. Now, one more example that we can add for prototyping is that now when you've got multiple versions of applications that are available that we're using nowadays, but you also have got the same applications beta version is also there. Now, what is this beta version? In this beta version, you do not know how this computer or how this application is going to react with that particular requirement that you are adding. Or you want to refine this particular requirement based upon the feedback from the user. Now let's take an example. You've got this YouTube beta version. Now what does this YouTube beta version has? The functionality, you as you're playing music upon the YouTube app, you exit, the music is not going to work. Whereas within the beta version, if you exit the app, the music still plays. So in here, this YouTube beta version, it is a testing phase. Now in here, in multiple beta versions, why you're creating the beta version? Because you're testing some specific functionality and you're going to take customer feedback so that you can refine this. Based upon this feedback, based upon those requirements, you're again going to add those changes within the main app. You could add them within the main app. Now there are multiple features within the beta version that do not get updated onto the main apps. Now what is the reason? There might not be good support that is provided. There cannot be a good human and computer interaction, or the algorithm or the software that you're using, that might not function properly. That is why there are multiple beta versions that are available within the beta version apps, and they are not available within the main apps, or there might be a chance that they might be updated late. By completely refining it, by doing multiple testing on multiple operating systems, because when the customer uses it, then only you get to know how this application is working. Now this diagram is going to give you a quick review. Now within this diagram, there is a prototyping model. Now with the first phase is communication. Within the communication, what happens? An end user is going to come and tell you what are the features he might like within the software, or a few specifications are going to be mentioned. Now based on that, as you're creating a prototype, now this within the prototype, you're rapidly developing. You want to clear you need to clear all of the doubts. What are the requirements that genuinely need to be there? Based upon that, you're going to make a quick plan, because you need to identify, or you want to draw a clear line between the requirements that are mandatory and that are optional. So you're going to make a quick design. Now the modeling of the quick design, these particular applications, these are basically made upon the visible aspects. Now what are the visible aspects within a particular software? Now the visible aspects within a particular software, those are the output display that is visible to the end user. The end user might not understand the complete coding part, but if he sees the output display format, he's going to understand, okay, yes, this is how your screen is going to look like. And the second one, it is your user interface layout. What are the different options that are available, where they are available. So this prototype model, it is built upon these two things, that is your output design and your user interface layout. And then this prototype is going to be shown to the end user. The end user is going to see this, what are the different applications, features, and based on that, he is going to give you feedback. Now, based upon this feedback, you're going to again add more features. This entire thing is this entire circle is going to be repeated until you get a acceptable prototype. Acceptable means that has got all the features, specifications, functionalities that were required for the end user. Now in here, if suppose the end user wants to make a change, he wants to change one feature, or he might want to add a particular feature, he might want to delete a feature, then that can also be done, because you are repeating this process until it becomes acceptable by the end user. This is the prototyping model. By developing a prototype, the end user and the developer both have got a clear picture of the requirements for the particular software, and it becomes very easy for them to develop the main version of the software. I've jotted down the same points. Now coming on to the disadvantages of prototyping model. Now, despite the advantage of prototype model, you also have got a few disadvantages. Now in here, as you're creating a prototype, you're creating this prototype in a rush because you need to clear the requirements. So whenever you're making a particular software in a rush, what happens in here, you might neglect the maintainability of the software and the quality of the software, because you are just going to pick whatever is first and you're just going to make a model out of it. So in here, your quality and maintainability might just go down, or it might be completely overlooked. The next disadvantage is the product delivery can be late. Now in here, this product delivery can be late because you do not have a complete idea of how many cycles it is going to take place to complete the entire software. You're unsure of the number of prototypes that need to be developed. And the use of inappropriate operating system or programming language. Now you might overlook a few disadvantages of a programming language, or how adaptability of an operating system while you're creating an operating system in a rush. Now moving on to the next model. The next model is called as the spiral model. Now this spiral model, it was developed by Barry Boehm. This was the person that invented this specific spiral model. Now this spiral model, in spiral model, you're going to develop a software rapidly. That is, you're going to develop a more complete version of the software. Now this spiral model, it is combination of two techniques. The previous technique that we have studied, the prototyping technique, and the waterfall model technique. Spiral model is combination of these two things, the prototyping model technique and the waterfall model technique. And in here, the additional new feature that we have within the spiral model is it is a risk-driven software, or a risk-driven development. That is, whenever you're going to develop a particular software, you are going to focus on the, if suppose a particular project has got a huge amount of risk, you're completely using new technology, new software, new tools. So in here, you do not know what the output is going to turn on. So at that point, you go for spiral model. When you're using new tools, new techniques, or new programming language, you're implementing it on a new operating system. When everything is new, you do not know what the output is going to be. The output is not known, so you go for the spiral model. It is a risk-driven model. It is a risk-driven model. And this is a realistic approach because many real-time projects use spiral model techniques, and this technique is used for very large scale projects. Because for a small scale project, if you're taking new tools, techniques, new operating system, you can just completely resolve. But when you have got a huge operating system to develop or a huge software to develop, you do not know which parts of the system are going to be compromised when you fix the other. Now, as I told you, this is a combination of the prototype model and the waterfall model. Within the waterfall model, you know the different steps, that is communication, planning, modeling, construction, and development. Now, within this technique, what happens is that you're going to follow a clockwise direction, that is starting from the center. That is, you're going to start from in here and you're going to move forward. Now in here, each of the segment, that is communication, planning, modeling, construction, deployment, this each acts as one segment. It acts this one segment in this entire clockwise direction thing. Communication acts as one segment, planning, modeling, construction. Now, as this iteration is going to go on at each instant, that is after completion of one cycle. Now in here, as you're starting in here, this entire green thing, this is your one cycle. Now within this one cycle, you're going to identify all the risks. Then in the next cycle, that is this red color, when in this entire one cycle is completed, again you're going to identify the risks. Then again, oh, yellow. In here again, you're going to identify risk. At each and every cycle, you're going to identify the risks and you're going to eliminate these risks. Now, when you're eliminating each of the risks, you're going to create a prototype. That is where you're using this prototyping technique. Now, this is an easy representation. The next diagram is going to be a difficult one. Now this diagram you can draw when this particular spiral model answer, if it is asked for 10 marks or if it is asked for 5 marks, you can draw the previous diagram. Now in here, you've got 4 different quadrants. Now within the first quadrant, now in here you've got the x-axis, you've got the y-axis. The first quadrant is determine the objectives. Second is identify and resolve risks. Third is development and test. And fourth is plan the next iteration. Now in here, what is going to happen is within the spiral model, you're going to start from gathering the requirements. The first cycle in here, concept of requirements. How you're going to collect the requirements, that is going to be you're going to start it in here. 1 second, just try it clear. Now, concept of requirements is what are the different requirements that the end user wants within the cycle. That is this within the first phase, you're just going to focus upon the requirements. Then the concept of operation, how you're going to operate on the requirements. Operation means what are the tools you might be using. You might be discussing that. Then when you know what you're going to do, you're going to make a schedule. You're going to identify when and how many members are going to work upon the particular team. Requirement planning in here means you're making a schedule. Then in here, now this within the first iteration for this particular process, you're going to identify if any risks are going to be there based upon the set of requirements that were given. Based upon that, you're going to make one prototype. One prototype will be developed. Now, what is a prototype? Prototype is a model. Now, when this first cycle is completed, after that, you're going to start with the next iteration. Now, within in here, you're going to take all the requirements. First, you have just seen the concept of requirements, what needs to be developed. In here, you're going to take the requirements of the software. Software requirements are going to be taken in here. You're going to gather all the software requirements. Then, based upon these requirements, you're going to do is verification and validation. Now, a clear thing that I'll tell you about verification and validation. This is verification and validation. Now, a simple example. Now, if suppose you're developing a shirt. Now, when you, for verification, you're going to check whether the shirt has got 2 sleeves or not, or any buttons are missing or not. You're going to check within verification. Whereas within the validation, you're going to check whether if this shirt is designed for the size L, whether it is going to fit for this particular person. And then you are also going to check the quality of the shirt. So this is the difference between verification and validation. Now we'll see verification and validation in terms of software. Now in here, you can say that verification is the developer's point of view. It is the developer's point of view. Whereas validation It is the client's point of view, how the end user thinks the system is. Now in here, within verification, what you're going to verify, you might verify documents, because in here you've got no sleeves and buttons. You're going to verify the document. You're going to verify the design that you've made for the prototype. You might check the test plan. Now, what is test plan? Now, as within the previous model, if you remember, or you might refer the previous video, within planning phase, what you do is you identify the different risks that might be available within the software, right? So in here, if there is a particular risk, what you do is you create a test case scenario. You create a test plan. That is, if suppose, now if I'll give you an example, what happens if suppose you're creating a Gmail login page. So there is a sign in button. Now within the sign in button, if you enter a correct email ID and password, it should direct you to the home page. If you're entering an invalid email ID and password, it should give you a pop-up page that tells you to enter a correct email ID and password. So this is a test case scenario. What happens if you give correct input? What happens if you give a wrong input? Now, whereas coming on to validation, within the validation, you're going to do different testing techniques are going to be applied in validation. And these can be black box testing technique, white box testing technique. These we are going to study within the later half of your software engineering syllabus. Black box and white box testing techniques are going to be applied. Now within this validation, you're going to also check the execution of the code, how the code is being executed. And within the verification, code is not checked in here. So there is a difference between verification and validation. Now coming back to the software verification and validation, after you've done the software verification and validation, you're going to make a plan, how you're going to work on it. Based upon that plan, again, risk analysis is done. As in every cycle, risk analysis need to be done. Then based on that, again, a model will be developed. Now when in here a model is developed, again another phase is going to start. Now within this drafting phase, now in here drafting means you're going to make a product design. You might write down the document. The designing part is done in here. You can say this is your designing part, software design. Now for the software design, again you're going to do is verification and validation. Now when you've done the verification and validation in here, you're going to create test plans. You're going to create the test plans in here. Based upon that test plans, you're going to do the entire testing you're going to perform, and then again do the risk analysis, again create a model. Then when a model is being developed, then you keep on adding the detailed design. So you can see within in here, you're starting from the basic, from nothing you're starting, then adding a few software requirements, then going to the design phase. So you can see that communication is happening. Then what are the 5 phases? Communication, modeling, communication, planning, modeling, construction, design. So in here, you're doing communication, planning, you're doing the modeling, then your construction, you're doing the construction, detailed design you're making the code, and integration. Now in here, integration in here means if suppose multiple teams are working, if suppose in spiral model multiple teams will be working, because there's a very huge project, it has got a lot of teams that are working. So in here, one person might be, now in here there is an entire software. Now if this suppose this particular software is divided into 3, one particular person in here might be working on the first module, the second on the second one, and the third one is working on the third module. So in here, all of these 3 are working differently. You need to combine all of these 3. That is called as the integration part. You're going to do the integration, and then now in here, when you're doing the code part, the integration part, then again you're going to do the testing. First you've created a test plan, then you're going to do the testing. After that, after testing, you're going to implement this entire software. That is the release of the software. After doing the testing, the implementation, this is the deployment phase, where the product is delivered to the end user. The end user is going to test all the features. He might be giving you a feedback on this. This is the spiral model. Now, a few advantages of spiral model is the monitoring becomes very easy. The monitoring of the software is very easy while you're using the software, while you're using the spiral model. Then changes can be made in later stages of the development, because every time you're developing a new prototype, you're not using the same old one. You can add changes as you're developing a new prototype. Third one is continuous risk analysis. As you can see, in every clockwise iteration, you are identifying if any risks are there. Now, when you're identifying the risk, you're going to make the test cases. Based upon that test cases, you can remove the risk. Then reviews are conducted early. That is, in here, as the reviews are conducted, that is, whenever you're making a prototype, you're going to ask customers feedback. As you, based upon that customer feedback, you're going to make changes within the software. Whereas within the previous model that we've studied, like waterfall model, you got late feedback after the entire software was developed. Then you got feedback of the particular software. So these are the advantages of the spiral model. Coming on to the disadvantages of the spiral model. Now, within the disadvantages, now as this is a risk-driven software, expertise are required in risk handling. Common developers cannot do the risk handling. You want expertise, you want a few people of your team to do the training part, or that is going to cost a lot, or else you're going to hire a few expertise from different areas so that they can assist you in the project. That is again going to increase the cost. Then it is a complex model, because at every instance you are creating a prototype, and it is complex because the requirements in here can also be changed. The cost is high because every time the prototype in here is being developed from scratch. There are strict rules to be followed. Now, strict rules are to be followed because multiple teams are working in here. All the teams need to collaborate with each other. They need to maintain the speed of the development of the software. Then the next one is the end of project may not be known early. Now, the end of project is not known early because you do not know how many prototypes you have to develop before you have the end project. How many prototypes need to be developed is not known. That is why you do not know when the end is going to be there for this particular project. The last model is the concurrent development model. Now, this concurrent development model, this model is also called as the concurrent engineering model. Now, as the name concurrent means that you're again going to have multiple teams. You're going to have a team A, a team B, a team C. All these are working concurrently at the same time. Now, this concurrent model is going to make use of framework activities. Now, what are framework activities? The activities that are used within the waterfall model: communication, planning, modeling, construction, design. Remember, you need to remember this in an order. Then software engineering actions. Now, what are the software engineering actions? Software engineering actions, it can be the work task, that is what are the different steps that you're following. Then you've got work products, that is what document, what file, or a particular report. This can be your work products, and how you're going to assure the quality of a particular software. These are the things that are going to be there within the concurrent development model. Now, in here, within this concurrent development model, what happens in here is you're going to follow the same communication, planning, modeling, construction, deployment tasks. You've got the communication, then you've got planning, then you've got the modeling phase. So now within the modeling activity, now this diagram, these rectangle like structures in here, these are going to represent state of the software engineering activity. That is in which particular state this particular software that you're developing in. Now, we are supposing that communication has been completed and planning is being completed. Now you're within the modeling phase. Now within the modeling phase, what can happen is that first, when you're starting at the start, the modeling phase is in inactive state. That is, nothing is happening. Now when this modeling state starts, has gone to the under development. That is, you're doing the modeling part. You're creating a design. You might be creating a design in here, or you might be creating a prototype. Now while you're creating this, now if suppose the end user, he wants to make some changes within the communication phase. Now when he wants to make changes, this phase, this under development phase, has to go in awaiting changes. Now within this awaiting changes, these changes that were requested by the end user are embedded in here. Changes are made in here. Now when the changes are made in here, after the changes are done, you're again going to check the software, because whenever you're making even a slight change within the software, you have to again do the testing part. So in here, you're going to again check whether it is going to affect another part of the software or not. You're going to again check, and then this particular software goes under review. Now this review will be done by the software engineer or the manager, the person that is responsible for the development of the project. If he says that this project is okay, then this is called as the baseline. Baseline means that the product that is being reviewed and agreed upon. That is, in here the manager has told okay, and in here the user has also told okay. That is called as baseline. When it is baseline, then you go for the done phase. This is one phase. The other phase can be if suppose the customer has not requested any change. The modeling phase will go from inactive to under development. It will directly go to review to check, to take assurance from the manager or the software engineer. Then it will go into the baseline phase. The user is also told okay. Then the done phase. After that, you're going to start with construction, and after construction, it is the deployment phase. So in here, this concurrent model technique, it is appropriate for projects when different engineering teams are involved. When multiple teams are there, one might be handling with communication, other with planning, one with modeling. At this time, it is used. Now the advantage is that it is going to give a clear picture of which state a particular project is. Now state means whether it is in awaiting changes phase, or it is in done phase, or it is in revision phase. You'll get to know that. It will become easy to understand because you know what state each module is in. Then new features can be added late in the project because it has got the awaiting changes phase. Then a disadvantage is that now, as I told, that multiple teams are working upon this project. So in here, as multiple teams are working, if suppose one requires a change, then it might result in the entire drop down of this particular project. A halt will be there for the particular project. Now, so coming on to the final comment on evolutionary process model, that is what all of these evolutionary process model, what is the problem in them, or what we say with the final summary of this. Now this becomes difficult in project planning. Now it becomes difficult in project planning because you do not know the number of prototypes that need to be developed so that you make a complete version of the software. Then the speed of the evolution is not known. Now in here, speed is not known. In here it means that you do not know how much time it is going to take to complete this entire software. Whereas the third one is, it does not focus on flexibility and extensibility and more emphasis on high quality. Now in here, while you're developing prototypes in a small amount of time, so that you get a clear picture of the requirements from the end user, you are neglecting the flexibility of the software that is on various platforms, whether it is able to perform well or not, and then whether the extensibility, whether you can add more updates to the software or not. That is not known when you're using the evolutionary process model. You're giving more emphasis upon the high quality only, whereas this flexibility and extensibility are getting neglected. The last one and the most important one is the time to market. Now, if suppose an end user comes with a request that he wants a particular software that needs to be launched within the market within a specific period of time. Now, if suppose you've taken a lot of time, suppose a year or a year and a half, something you've taken to develop a particular software, some specific features that were not there within the market. Now assume that a month before or 2 months before, another company launches the very same product, a software with the same features that you planned. So in here, if you're unable to deliver the particular software to the market within a specific period of time, this particular software becomes useless and there is no use of this particular software. The entire money, the entire resources, the entire technology, tools that you've taken for this particular technology, it has all come to waste, because if suppose this particular features, they were launched at a very great price. So who's going to come for your particular project? You need to add a few more features. Again, more input, more manpower needs to be given as input for this particular software. So this is the final comment on the evolutionary process model.